Hello, my name is Thomas Dvorak, and this presentation is on corporate computing, utilitization, and the dying PC. Now, before we start, I'd like to point out that this presentation is based upon the article, The End of Corporate Computing by Nicholas G. Carr. And in the beginning of this article, he states that IT and electricity are very much alike as far as scalability and utilities go. So he argues that information technology will essentially be a utility like electricity. And he does this because he says IT will be standardized eventually, and that its complexity does not outweigh the ability of it to standardize. However, I disagree with this because electricity is on a grid. There isn't different types of electricity once you receive that electricity. It's all the same as far as when it's coming out of the outlet. And the currents are the same as well. Whereas IT has multiple types of software built into it, and on top of that, it has applications built on that are not always able to run on different type of operating systems. And so this adds complexity, but it also affects the scalability as far as how many clients or you can really have. Because if you, let's say you have 100 clients for IT, that only makes the software challenges between those IT as you gain more customers more exponentially more complex. You have more software to deal with. Whereas with electricity, if you simply have another customer, you just make sure that the grid is providing enough power. There isn't any specialization the customer generally needs, and there isn't like a different level of electricity as far as like quality or anything like that. So I feel like that's an important difference, and it can affect the scalability of like a utility data center. Some further barriers to utilitization of a data center. The operating software has not been standardized. So here are some pictures. There's Windows, there's Apple's OS X Mountain Lion, there's Linux, there's plenty of operating softwares that are built to run a certain way, and applications built upon those operating systems are not universal. Whereas application on Windows 8 may not work on Mountain OS. And typically the way an application is designed, it's designed with a certain OS in mind. So, and then it slowly disperses to the other OSs if it is dispersed at all. And so that is a major barrier as far into utilitization, because there's going to be different types of softwares, different types of applications, and being able to service these all is very hard. And it creates a lot of complexity. However, I must also admit that what we're studying in class, virtualization, breeds hope to this issue, because virtualization allows you to use the same processor and RAM to run different types of softwares, and then you're able to run all those applications as long as you have the power to run multiple OSs. So if utilitization does happen, it will definitely have to, or utilitization of data centers, it'll definitely have to happen with virtualization in mind. There's no way they can rely on the classic one server, one OS, one application, because it will simply not be scalable and not worth the costs. Now moving on, I do feel like virtualization is a key, would be a cornerstone if it did happen, but I also want to point out why it may not work quite as well as the author thinks it will. So as I stated, it runs multiple virtual OSs or applications on a virtualization layer. So this can be VMware, and the reason virtualization is good is because it uses the full processing power of the computer, and it may cut down on the IT budget, whereas you have much less hardware, much less cooling, much less electricity costs, and so therefore the IT budget may go down, but you must also realize that virtualization is very complex. It creates more security hazard, and it creates more like disarray between maybe like a physical, there may be like confusion between a virtual OS system and a normal OS system, and the applications running on it may not completely intertwine or be able to interact with other computers or the internet the same way. So it may cut down on IT, but it may also not, because the hardware is less, but then each piece of hardware has more complexity and software to it, so it may cut down or it may not, and that's something I don't know yet. So tying it into utility data centers, like I said before, utility data centers must have virtualization. However, the main issue I see with utility data centers being successful is that virtualization not only would happen at the utility centers but also at the corporations themselves. And this may alone cut costs enough to where having it serviced out may not be worth it. It may save you a couple more, but then also there's other issues that come into play, like security, that I'll talk about later. So the bottom line is, I feel like corporations are going to self-virtualize much, or would rather self-virtualize their IT than give their whole IT infrastructure to a utility data center. So as I hinted before, security, I feel like, is probably the breaking point where a utility data center may not work right now. There's in the article they states that right now there's multiple data centers even for each company. However, there are intrinsic benefits to this. If a server is running one application, one OS, there's less complexity, and you know that application will always work. Whereas with virtualization, it gives you more points to attack the security, and this would be at the utility data center. And it also creates, like, if somebody hacked into a data center and you have multiple data centers and they screwed that one up, it may not have revolving effects onto the other multiple data centers. And he says this is like a bad thing, but there's also benefits, and I think these should be considered before a company would quickly go into a utility data center. The third point here, attitudinal dilemmas. I feel like there's an attitude where if you have your own IT infrastructure in your own company, it's more secure because you can directly access it and it's much closer, rather than having to call someone or have a video conference and ask them about the issues. And this last point, corporation culture creates mistrust between departments. As stated in class, if there's mistrust between the finance department and the marketing department as far as servers and the data they have, imagine the mistrust between one corporation trusting all of its IT, its competitive advantage, to a data center utility that has hundreds of clients like that. So I just feel like there's just a general mistrust that'll always be there. And until security is absolutely bulletproof, which I feel like is very unrealistic because there's constantly changing software and constantly changing applications, there's always going to be a way to attack, to the point where it won't be the risk. It won't be worth the risk to have a utility data center with your IT, especially if you put self-virtualization on your own data centers. And this is mainly in the context of large corporations who would drive the initiative for a large data utility center. Now switching gears right quick, there's the conflict between the desktop PC and thin clients. And this was mainly, there was a quote by Larry Ellison stating that in the mid-90s that a PC is a ridiculous device. And although I do agree to some point, I wouldn't say that. I feel like it is obsolete today. Processing power has increased dramatically in thin clients, just like Moore's Law. Every 18-month processing power doubles. I feel like that far outstrips the business applications that have been created. So the processing power has gone much faster than the business applications today, because they generally just have computations, and the graphics, the processing power can handle the low-end graphics. It's only the high-end graphics that may be hard to use. And also, PCs are calibrated much like servers, where they're going to run at 10 to 20% of stress on average, and they're built to withstand the peaks. However, this causes a large amount of cost. As far as the PC itself goes, it's much more expensive than a thin client, and it has large costs in electricity. So iPads and smartphones can even run new business applications. I'm sorry, it shouldn't be Chromebooks. It should be tablets, but they can run many business applications. The big advantage is portability. You can move it somewhere. You can be ready to work on a competitive advantage anywhere, and you don't have to wait till the next day to get it on your computer. And then also, I feel like PCs will be used, but it'll be mainly because of their display and applications that require large processing power. And lastly, the picture down here is Microsoft Surface, and I feel like keyboards were something that made PCs useful and very good. However, now thin clients even have keyboards. So like the aspect of keyboards being very quick, shortcuts and stuff like that can even now be applied to thin clients. So I feel like it's another reason why the PCs may not be used. Now finally, in conclusion, I feel like virtualization will be a source of cost savings for corporations before utility data centers, and that's the main key. Although there's benefits to both, I feel like a corporation will much rather self-virtualize than outsource all its IT to a data center. And then lastly, I feel like the security aspect and the missing trust because of the rapid change of software and the complexity of virtualization at these data centers will always make a corporation on edge. Is their data really safe? And I feel like that's the breaking point where the cost savings from self-virtualization will be worth it, whereas the extra slight more savings from having a data center as a service will not be worth the security risks. So thank you for watching this presentation, and I hope you have a nice rest of your night.